these straight lines, these variable straight lines, okay, these are also called generators. Okay, these are also called generators. So a cone is a surface generated by these variable. Okay, so good morning everyone. Today we'll discuss a topic about paper 1, that is analytical geometry, and the topic of today is cone. Okay, so you must be familiar with this word cone. Okay, you must have eaten ice cream. It is in a conical shape. This is a form of, it is cone. Okay, so till that time that was the easier thing to do, but now we'll study the mathematical equation of the cone. Okay, so technically what you can say about the cone, if you have to say what is a cone, and when we say equation of a cone, we mean that if I say this is a cone in 3D, okay, consider this is a 3D image like this one, okay, this is a cone. When I say equation of the cone, I mean that if I give you an equation, every point on this cone, be it here, on this cone satisfies this equation. That is the meaning of equation of the cone. Okay, like you have studied the equation of the sphere. So equation of the sphere is all the point in x, y, z Cartesian coordinate which satisfied, which lie on that sphere must satisfy that equation. Okay, so basically what is cone? Cone is nothing but cone. Suppose this is a fixed point, say this is called vertex. Okay, in this case here this is the vertex. Okay, and you draw many lines here, many lines. Suppose this is a point and you draw a line like this, infinitely many lines. So what shape do you think it will form? It will form a cone. If you take a fixed point and take many lines like this, okay, passing through that fixed point, then the locus of this point, this locus of these lines is called cone. Okay, that is, suppose it is a fixed point. Okay, so this line, this line, this line, this line in the circular portion is called as cone. Okay, so you can imagine it. Suppose it is a cone. Suppose you imagine an ice cream. Okay, ice cream cone. Okay, so you take the point, the lowest point, okay, that is the vertex, and all those lines, infinite lines passing through those points, and given by another condition is also needed, that is which is we call a guiding surface, which we'll see later in this video, that would be needed, or any other condition. So all those lines forms a cone. Okay, so now we'll see the formal definition of cone. Okay, which says that a cone is a surface generated by variable straight lines. Okay, a cone is a surface generated by a variable straight line. Okay, that was I only was saying that these straight lines, these variable straight lines, okay, these are also called generators. Okay, these are also called generators. So a cone is a surface generated by these variable lines. Okay, passing through a fixed point, that why I was saying that is called vertex. Okay, and satisfying one more condition. One more condition could be anything. It could be, say, let's say it could be the guiding curve. Okay, that it touches a given surface or intersects a given curve, be a hyperbola. Okay, and I say all those lines which passes to a vertex touches this hyperbola. Okay, then this called a cone. Okay, or I say that all those lines, okay, lie on a surface or cuts a surface, then it is a condition. So condition would be given in your examination. Okay, for now you can understand that a cone is a surface generated by variable straight line, or we can say that a cone is a locus of straight lines. Not mathematically it is right, but for your understanding I am saying this, that a cone is nothing but a locus of the straight lines which passes through a fixed point and follows one another condition. This could be a condition that these are envelope of a surface, or it passes to a surface, or it is tangent to a surface, or touches to a surface. It could be any condition, okay. But the given point is that these lines collectively, the locus of these lines is called cone, and these lines are called generators because they generate the cone, okay. So I think till now you must be clear about the understanding of what is mean by cone, okay. So moving ahead, now the first topic in our hand is cone with vertex at origin, okay. For simplification, we'll first understand that all the cones whose vertex is at origin, that is at 0 0 0, okay. Cone is a three-dimensional I would say a shape, so we'll take 0 0 0 as origin, okay. So here it is given that the equation of the cone with the vertex at origin is homogeneous second degree equation in x by z, okay. It says that any equation, okay, of a cone whose vertex is at origin, then it forms a homogeneous second degree equation, okay. First of all, for homogeneous second order equation, it means that the terms there would be of the form x square plus 2y square plus 3z square plus 2xy. See, this equation is homogeneous. Suppose this is equal to 0. This equation is homogeneous because all the powers is 2, maximum power, and all those power has 2. Suppose I say this is x cube, okay. Now this is not a homogeneous equation of degree 2. In fact, it is not a homogeneous, okay. Or you can say that, or if I say I added x, then it is also not homogeneous. If I added 3, it is not also homogeneous. For homogeneous, you see the degree is 2. This xy is 2, this could be yz, this could be xz, but the degree is 2. Another way to see a equation is homogeneous or not, suppose if I take x square common from here, okay, so we get 1 plus 2y upon x whole square plus 3z upon x whole square plus 2y upon x, okay. So we can say that now it is of the form x square f of y upon x comma z upon x, okay. So it is a function with y upon x and z upon x. You won't see any term of, suppose if you have taken here x cube, then you must have gotten a term x here. Then you can't say that this is a function of y upon x or z upon x, okay. So I think you are clear with the concept of homogeneous, what is mean by homogeneous. Now we see that it is saying that equation of a cone with vertex at origin is always homogeneous second order equation, okay, is always a homogeneous second order equation. See, this won't come in your examination, but for your conceptual clarity I will show you. Suppose let us consider the general second order equation, general second order equation, okay. So it will be of the form ax square plus by square plus cz square, okay, plus 2f plus 2fyz plus 2fyz. This is a standard way of writing 2gzx plus 2hxy plus 2ux plus 2wx y, sorry, uvw, this 2vy plus 2wz plus d equal to 0, say equation 1, okay. So this is the general equation in I would say a second degree equation, Okay, second degree polynomial. Okay, it has x square in terms y z zx x y z. So it says that if it is a cone which passes through origin, or I would say not passes, the vertex is at origin, the point which I said from which all the generator passes, if that is at 0, then it says that it is homogeneous. Okay, it means that if I say vertex is 0, then you will only get these terms, this, not these terms. Okay. Okay. Say equation 1. Suppose this is the equation of cone. Okay. Now let us suppose any point. Let us suppose any point x1, y1, z1. Okay, on the say this point we name as P. Okay, on the cone. Okay, so if O is the origin, then the equation of the line OP would be x minus 0 upon x1 minus 0 is equal to y minus 0 upon y1 minus 0 is equal to z minus 0 upon z1 minus 0. This is clear by the concept of straight lines which I taught you earlier. Okay, you won't understand the cone if you don't understand the concept of straight lines. Okay, now say this is equal to r. Okay, we know that what does this r means. I have told you in my previous lectures also that if this is the direction cosine, not the direction ratio, please mind this. Some people confuse that if this is the direction ratio also, then they say that the distance is this. So for now, if you say this is r, then any point on this line, any point on this line would be rx1, ry1, rz1. Yes, clearly it is x equal to rx1, y is equal to ry1 there. So any general point, or I would say parametric point, would be rx1, ry1, rz1. Okay, now since this OP is a generator, I told you that OP is the line generator, then any point on this line would be on the cone. So this point also lies on this cone. So this must satisfy equation 1. So if I put this in equation 1, okay, so we'll get r square ax1 square plus by1 square plus cz1 square plus 2f y1 z1 plus 2g x1 z1 plus 2h x1 y1 plus r. We get a quadratic equation in r square. Okay, so for plus r times 2u x1 plus 2v y1 plus 2w z1 plus d equal to 0. Okay. Now see, now till now it is clear. Now see, I told you this line OP is the generator. So every point lies on the cone. So for every value of r, this equation must satisfy every value of r. And it is only possible for every value of r if this is equal to 0, this is equal to 0, and this is equal to 0. Okay, if this is equal to 0, this is equal to 0, and this is equal to 0, then only this can be true for every r. Okay, if you don't take this as an identity, then what you see, that since r square is of quadratic order, then you say it will be satisfying only two values. But again, I told you OP is the generator. So all those points on this line OP all of these infinite points on this OP must lie on the cone. Okay, must lie on the cone, and so for this R, it must satisfy equation this for every value of R. For every value of, I say R equal to 1, this equation should satisfy. I say R equal to 5, this equation should satisfy. If I say R equal to 1000, this equation should satisfy. Okay, because R is nothing but it is a Rx1 is every point. If we change the value of R, we get every point on the line. Okay, so it must satisfy for every value of R, and this is only possible if this is equal to 0, this is equal to 0, and this is equal to 0. Okay, it is an identity. Okay, that means this is equal to 0, that is ax1 square plus by1 square plus cz1 square plus 2f y1 z1 okay, and another we get ux1 plus vy1 plus wz1. Okay, I have taken 2 common and that would be 0, and this d equal to 0. Okay, so what does this shows us? That equation, this cannot be equal to 0. This cannot be, this is true, but this is it says this is the equation of a plane. I have taught you in the previous chapter, this is the equation of the plane, and in your intermediate level also you must have studied the equation of the plane. This is the equation of the plane, and here it is given that that point lies on the cone, not a plane. So okay, so this would be the only the equation of the cone. Okay, and which is homogeneous in nature. Okay, which is homogeneous in nature. So this for a UPSC point of view, see, I am here just to teach you UPSC, so you could get maximum marks in UPSC optional, and not that you get good marks in mathematics, you are a great mathematician, but I told you this proof. But the point is, this proof won't come in no examination. The main thing is, you must remember that a vertex is if a vertex of a cone is at origin, then it is a homogeneous equation, and if the vertex is not at the origin, then it may consist other terms like terms of x, terms of y, terms of constant, here d is 0, that could come. Okay, and now this is the proof part. This is just for your conceptual understanding. None of these things would be coming in your examination point of view. Okay, so moving ahead, find the equation of cone with vertex at origin and which passes through the curve this. Okay, which vertex at the origin and which passes through the curve this. Now this is from your exam point of view. This question comes in your examination. So in this type of question, what you do is you just make the equation homogeneous. Okay, find the equation of vertex at origin. Since vertex is at origin, so I already told you that the equation of the cone would be homogeneous in nature. So if you want this to, you want to combine these two equations and form a homogeneous equation, and then you will get the answer. Okay, so I'll teach you how to make homogeneous. These things, if you have prepared for the IIT JEE examination, the JEE advanced level, then in that section also, in the coordinate geometry, we used to do this homogenization. Okay, but if you don't know, see, this is a very easy thing to do. What you do, you take a parameter t, you introduce a new parameter t, okay, and make this equation as homogeneous, okay, of second order. See, it is ax square. You don't have to make this second order homogeneous because it is already in the form of x square. This is by square, nothing to do here, cz square. For 1, we can write 1 into t square. Now this whole equation is homogeneous in nature. Okay, this whole equation is homogeneous in nature. Similarly, for that what you can do, alpha x square plus beta y square plus 2z, and this is of order 1. So I have to make it of order 2. So what do? I multiply it with t. Okay, so say equation 1 and this has 2. So from 2 we see that t is equal to alpha x square plus beta y square upon 2z. Okay. Okay. So here we can see that we get t is equal to alpha x square plus beta y square upon 2z. And then what do? You put this value here only, and then you will get the equation of alpha x square beta y square equal to 2z t. Okay. Yes, and then you can find put the value from 2, the value of t from 2, and put it in the equation 1. Then you get the value of, you get the equation of the cone which passes through origin, not passes through origin, whose vertex is at origin. Not, we can not say that it passes through origin, its vertex is at origin. Then you can say that it is a equation of cone. That is so easy thing to do. Okay. We have another question here of that type. This says that the plane x upon a plus y upon b plus z upon c, okay, meets the coordinate axes in a, b, c. Okay. Now prove that the equation of the cone generated by the lines from OA is the origin. Again, lines generated drawn from O to meet the circle ABC. Meet the circle ABC is this. Okay. Again, what do we have to do? We have to just use the homogenization. Okay. What do? We homogenize it. Okay. So it says that, first of all, see, there is a plane. The plane x meets the coordinate axis at ABC. Prove that the equation of cone generated by the lines drawn from O to meet the circle ABC. Okay. Now this equation of the circle, is nothing but I can say that it is the intersection of the plane and a sphere. See, I have taught you this in your sphere portion. See what happens, that for a circle, if you consider a sphere, okay, and suppose a plane cuts it, okay, so what does the image you form on the plane? You get a circle here. So circle is nothing but, circle is a intersection of sphere and plane. So all the equations which satisfy all the points which satisfy this sphere and this plane would be part of the circle here. See, if you take a ball, a spherical ball, and you cut it, okay, so what you can imagine, what you get here, you get a circle. Okay, so all those points which satisfy both the circle and this plane would be this circle only ABC. To meet the circle ABC, where A is the point on ABC are the intercept, where A is this. See, once you understand this, A is this, A0, 0. This is 0, B0, and this is 0, 0, C. It says the circle ABC. It says that a circle ABC means a circle passes through these 3 points. Okay, and this could be formed if equation circle is nothing but intersection of sphere OABC, okay, this is O, okay, and this OABC, this sphere is OABC, okay, and the plane and the plane x equal to a plus y equal to b plus z equal to c equal to 1. Okay, and equal to 1. Okay, so first of all we have to find the equation of the sphere OABC. So equation of sphere, see, we know that it passes to 4 point A0 0 0 B 0 0 0 C and 0 0 0. Okay, so you can easily calculate the equation of the sphere. Okay, and I have taught you in the topic sphere also. In fact, my videos are there on the topic sphere where I have taught you to how to find a sphere if the 4 points are given, equation of the sphere if the 4 points are given. So okay, and there I told you also that this OABC sphere is a special sphere which you must know. Okay, which you must know since it is a special sphere. Okay, and now you see we are getting direct use here. Okay, so equation of the sphere is x square plus y square plus z square minus ax minus by minus cz equal to 0. This is the equation of the sphere. Okay, this is the equation of the sphere which you are, if you going to solve this you will get this only. Okay, I told you that time also, you can see my previous video also in the YouTube section, that when I told you I was teaching analytical, I was teaching sphere, then I told you that this sphere is important. See, here it is, we are getting the use here. Okay, okay, so we have two, so now we have two equations. I got the equation of the guiding curve to be the circle ABC. Okay, so if you want to find the cone, now we see the question here. It says that prove that the equation of the cone generated by the lines drawn from O. First of all, the vertex is 0, then the equation must be homogeneous. Meet the circle ABC is this. Okay, so what do? We homogenize. We again use the homogeneous principle. What I told you, how to make this equation, combine these two equations such that they form homogeneous form. Okay, it's very simple. It is very simple. What do you do first? I told you this is x upon a, this is degree 1, you write t. Okay, plus y upon b, again t, plus z upon c, t, and here it is 1. So you write t square. Say equation 1. Okay, here again for x square you write only x square, since it already of degree 2. You have to make the degree 2, where you have to use t, where you have to use t square, use t square. Since here it was 1, so I use t square. Again y square would be, okay, now here it is minus ax. Okay, so it will be minus axt minus byt minus czt. Okay, so from 1 we get the value of t to be, if I calculate the value of t, okay, so from 1 t is equal to, this t and t cancels out, we get x upon a plus y upon b plus z upon c, if these t cancel out, and I put this value of t in 2. Okay, putting this value in 2, okay, so we get x square plus y square plus z square. Okay, we take this t common, or I write ax plus by plus cz into t is equal to 0, and for t if we put this value, that is x square plus y square plus z square minus, for t I can write this x upon a plus y upon b plus z upon c into this ax by cz, ax plus by plus cz equal to 0. Okay, okay, so if I now proceed to solve this, so we get x square plus y square plus z square minus of multiplied by this is x square, this multiplied this is y square, this multiplied by this is z square. Okay, now this multiplies by this is b upon a xy, okay, c upon a xz plus this a upon b xy, okay, and c upon b yz plus a upon c xz plus b upon c yz equal to 0. Now these x square, y square, z square cancels out and we take xy as common. We have b upon a plus a upon b plus, if I take yz here, yz, so we have c upon b plus b upon c plus xz c upon a plus a upon c equal to 0. So this is a this is a homogeneous equation, xy, yz and xz. Only 3 terms are there. So this is the equation of the required cone. Okay, this is only we have to prove this only. Yz b upon c plus c, this only we have to prove. Okay. See, I have chosen this standard question. This question is a very important question, and even this question has come in your civil services examination. Okay, so nothing for a cone. The point here, if I revise this for you, the thing is, if a cone has a vertex at origin, then all you have to do is you have to homogenize those two equations. Okay, you may use these two equations to find a homogeneous equation, and that will be the equation of the cone. That's it. Okay, for equation of the cone. See, in this case, and I told you how to homogenize this. Okay, you for this ax square, by square, cz square, for one you use t square. Okay, and for this you say t here. Okay, and once you get the value of t, please get the equation, and that is your answer. These question comes in your examination, and a very easy thing to do in your examination. Okay. Okay, so this question is an important question. See, here also prove that the equation of a cone generated by the lines drawn from O to meet the, see, this O is the origin, to meet the circle ABC. Okay, I have told you in the, see, now we don't write in the 3D geometry, we don't have the equation of the circle as you had in the in your class 10th or 12th level. Okay, in the 12th level I was say that where you write the equation in 2 degree. Here in the 3 dimension, the equation of the circle is, it is a intersection of a plane and a sphere. I told you, if you cut a ball from middle, you will see a circular portion. And what is this? See, all those points, okay, all those points, suppose this is a plane and this is a circle. If I cut this, all those points which satisfy the sphere also and this plane also are the equation of the sphere. Okay, so combinedly we write, if I have to write the equation of a circle ABC, I write the equation of the sphere and the plane, and that two combined forms a circle in 3 dimension. Okay, forget what you learned in your class 12th level, that is on 2 dimension, but in a real world analysis we see the whole world in 3D figure. Okay, so here the equation of the circle would be nothing but the intersection of the sphere OABC and the plane. And then what I do, that I only homogenize it. Okay.